Next, I'm going to show you how we can keep track of statistics on simple things like prevalence and incidence in a model like this, if I may. So we want to, I mean, this is all nice and good, and it's pretty, but it's not anything that gives us any particular details on what's going on. I mean, we can kind of go and look at, you know, the state of different people, but, you know, what we'd like is some information about how many people are infected at a given time. So we're going to put in place a mechanism for reporting, okay? And this mechanism is going to periodically report out how many people are currently infected and how many people have become infected, the incidence, so the prevalence as well as the incidence over since the last time that it fired. That's the plan, okay? Okay, so how are we going to do this? Well, AnyLogic actually offers some nice mechanisms for doing much of that declaratively. The mechanisms for the prevalence. The mechanisms for the incidence part aren't as pretty, to say the least. Okay, so let's go to population. And we see in population, there's a thing called statistics. I'd like you to go to statistics and go down to statistics, and you'll notice that we can name a statistic. We could say like prevalent case count, the count of people who are currently infected. And guess what type it is? Is it an average, a minimum, a maximum, a sum? Well, it's a count. And what do we provide here? Well, we provide the condition of people that need to be counted. We're going to describe what people need to be counted according to a condition. We'll say if a person matches this condition, they'll be counted. We have to say if the person's X matches this condition, we'll count them. This is a count of people who match a certain condition. Okay, so what's this condition going to be? Well, we want to know, are they infected right now? Oh, sorry, are they, I think we'll ask, are they infective right now? That's what we mean by prevalent case count. Okay, so are they effective? Well, how do we know if someone's infectious? I'm using infective and infectious in the same way. How do we know someone's infectious? Could you tell me? How do we know someone is infectious? What could we do to ask, is this person infectious?
The color is red.
Okay, the color is red, but what else? What makes their color red? It's by virtue of having been what? It's by virtue of being in this state. So we can ask, are they in this state right now? It's by virtue of being in the state the color is red. So you're right, color and red and being in the state are kind of coextensive, but it's really by virtue of being in the state that the color becomes red. This is kind of an indication that they are in this state. And really it's being in this state that leads them to expose others. So what we just need to ask is, are they in this state? Okay, just got to ask, are they in the infectious state? Okay, so here we go. So we're going to go to population. You notice I went to population. I should have emphasized statistics are specific to the population. So for this population, it's prevalent case count. It's a count of people that match the certain condition. What is this condition? Well, we kind of want to say, don't do this. We kind of want to say, if the person is in the state, is in a certain state, but it doesn't know. I mean, this could be a model of service dogs. This could be a model of physicians and nurses and nosocomial transmission. This could be a model of, of deer and chronic wasting disease, and so on. It doesn't know your model's about person, so it actually has a more generic name. It says, hey, just use the name item. Item is referring to whatever it is. In this case, it's a person. So the condition is item dot in state, and we want to say infectious. We want to ask, are they in the state infectious? But if we just try to kind of do that, it'll say, I don't know what infectious means. I can't find it. After all, there could be deer infectiousness, person infectiousness. So we want to say person dot infectious. It's kind of infectiousness in the person. This may sound odd because you've been used to seeing it like this particular person, but this is infectiousness, in person. The person sort of infectiousness, not the doctor's sort of infectiousness or the deer sort of infectiousness or the service dog's infectiousness. It's a person's infectiousness. Okay, you say, yeah, okay, fine. Satisfy it, fine. And it's a happy camper. So we say, hey, it's going to go through each person in the population and say, hey, is this person in this certain state of infectiousness, as judged by person? And it'll check if they're in that state. And it'll count up the number in that state. That's what its job is in life. It's going to count them up. Okay, so let's run it. Here we go. You ready? Here we go. Okay, so here we go. We can click on population. You'll actually see it. Oh, look at that prevalent case code. 16, 17, 22, 23. Oh, look at that. It's escalating. It's oh, now it's going down. Oh, look at that. It's going down. Why do you think it's going down? Anyone? Well, it's the nature of these things. They spread. If there's no reinfection, they spread. It's like burning wood, right? They spread, it burns the wood, it gets bigger, fire bigger. Some case it peaks, but it's finding new wood to burn is rare. It's increasingly rare. It can only spread, to fewer and fewer pieces, and eventually it burns its way out. Right? Eventually this will go to zero. So it's by virtue of that statistic we have that little nice readout, but that's pretty anecdotal. I mean, we sort of clicked on it and saw it. Let's do something a little bit better than that if we could. Okay, so let us add ourselves a chart. Let's go add a chart. Ladies and gentlemen, let's go add a chart. Okay, so let's go to the palette. And we're going to go to a new part of the palette, the analysis palette. And we're going to add in a time plot. There we go. Time plot. Okay. There we go. And we'll call this prevalence time plot, in terms of call it, or maybe we'll call it, I think of it as sort of stocks time plot, because we could plot out the number that are in exposed and recovered and susceptible as well. Okay, stocks time plot. I like to call them stocks. You could call them compartments if you want to, whatever. Okay, we're not going to need to refer to this. Okay, great. And it's going to plot out a value, and right now its title is going to be infectious prevalent case count. and its value. And here's the rub. Here's the rub. That statistic which we put in, it was in population. What's the statistic? It was called prevalent case count right there. We named it. We added it in with this. We added it in, prevalent case count. Yeah. Okay. So what do we want to do? Value him. I want to do a value. Okay, cool. What value do we give it? We give it population dot, let it spell it out for you, prevalent case count. Make sure it's begin paren end paren. That means it's calling it, saying, give me your value. You know, it's calling it, it's saying, compute this. There we go. And we'll do it every day, and we'll display up to 1,000 samples in a time window of 1,000 days. Sure, we could have said model time. That's fine. So what did I do? Here I put value. I said infectious prevalent case count. I said what value to do. It's prevalent case count in infectious. That was the name of the statistic we had added there. And then we wanted to do it every 1 day. This was the default. And I said display up to 1,000 samples in a time window of 1,000. Honestly, I find AnyLogic's default settings those pretty trying, and normally it leads to this kind of snake-like appearance where it's not fully visible, only recent ones, and I find it distressing. Okay, so now, I should have built it. I'm sorry, I grew too eager. Okay, so here we go, and there's our prevalence case count, and you could see it went down, and I'm going to pause it. You can also copy it with this copy, and now I can go to Google Sheets maybe, or OpenOffice, LibreOffice, Excel, whatever your preferred sheet is. I'll go to Google Sheets and I'll create a new sheet, and I'll go and I'll paste it in, and there's my exported data. So I just taught you how to export as well, or one way to export. Okay. And naturally you could, if you wanted to, you could take a screenshot of this and put that in places as well. Okay, so here we've had it kind of report this for the prevalent case count, and that's nice. It's great to be able to report on that. But what if we wanted to report, forgive me while I'm still eating my lunch here, on a statistic of equal interest, the incident case count, the new infections? How do we do that? Well, alas, despite my entreaties over the past 10 years, 9 years, AnyLogic still hasn't gotten around to sticking automatic support for that in. So you gotta kind of do it yourself. That's the bad news. The good news is it ain't bad. It's not too bad, but it does take a little bit of mechanism. And I'd like to show you how, if I may. So there's no analog to kind of this declarative thing where you go in here and you say, count the number like this, or take the average of it. There's not a good way. Oh, I'm sorely tempted to show you something. Yeah, okay, I gotta show this to you. Okay, I'm gonna do prevalent fractional. So fractional prevalence. Fractional prevalence. Do it as an average, and it's an average over some expression. And the expression it's going to be over is If they're infectious, then yeah, give it 1.0. Otherwise, give it 0.0. It'll take the average across the population where we treat people who are infectious as 1 and not infectious as 0. And this will give you the fractional prevalence. And it's short and it's sweet and it's not NP complete. So it's here we can do that, and we'll see the fractional prevalence is just the prevalence divided by the population size, like 100. Okay. So there we go. Okay. Great. So okay. So now we're going to do incidence. Now, incidence is a little bit more textured, and I'm going to take a mouthful of my lunch before I do that. Okay. So for incidence, this is what we're going to do. We're going to have a running tally. It's just like what you might think. You're a public health agency, a small, of a small town. Every time you hear someone new has been infected, you tally it up, counting 1, 2, 3, 4, and at the end of the week, you write down your tally for that week, and then you wipe it clean, and you're starting again at 0. In the next case will be 1, 2, 3. Same basic idea. You have a running tally, you report it every week, you wipe it clean, and you go on. That's the basic gist. But I'll show you a nice little mechanism or two in the process, if I may. Okay, so let's do it. Now I'm going to actually do incidence, but I'm going to give you a free one as to cumulative incidence. So here we go. Now I'm going to do something which may puzzle you, but this running tally will not be on a per person basis. It's going to be for the whole population. You're a public health manager for this town. You run a running tally for everyone in the town, not on a per person basis. You could do it if people got reinfected. You could keep track of how many times they've been infected on a per person basis. But we won't be doing that yet because right now it's an SEIR, not an SEIRS. Okay, so let's do it. This is kind of interesting, but it's short. Okay, so palette, we're going to go to main. Make sure you're in main, and you're going to go to variable. It's a variable. What type of variable is it? It's going to be a count, ladies and gentlemen. What type is a count? Well, I'll let you ponder it while I add them in. There we go. So I'm going to add in a variable called let's say weekly incidence. I'll do it weekly just to show you with a bit of sort of a bit of versatility. We could do it daily. Okay, the incident. So I'm going to call it, I'm going to be more explicit. Weekly incident case count. Guess what a count is going to be? What sort of thing? Is it a double? Is it a Boolean? Is it a string? Is it a date? Is it a person? What is it? Is it a message? Or is it a what?
Integer.
It's an integer. You speak well. Integer. And it's going to start at 0. This is going to be a running tally. It's going to start at 0. We're going to take someone down each time they get sick. And we're going to report it out and start again at 0 the next week. We're going to report it out weekly. Could report out daily. The same idea would hold. Okay. This is what we're doing. Ladies and gentlemen, this is what we're doing. Okay. Okay, great. And I'm going to add another one. This is the one you get for free, or almost. This is going to be called cumulative incident case count. This is cumulative. This is over time. I'm going to keep track of everyone that's gotten infected so far. All right. It'll allow us to figure out the attack rate. All right. So we go there and we go and we do int. All right. And the initial value will be 0. Oh, no, not 0.0, 0. It's a good old honest, not 0.0. No, don't give me that stinking 0. It's 0. It's an integer, 0. That's it. That's it right there. Okay, great. Okay, we're cooking with gas, and we're gonna just gotta increment these. Okay. Okay. So, where will these be incremented? What in the model would increase these? Can anyone tell me? Like, under what condition would the incident case count cumulatively go up, or the weekly incident one? Under what condition would that tally, would a stroke be added to that tally? Can anyone say? Under what condition? If somebody is what? Under what condition will we say there's one more case? If they are newly what? Begins with an I, ends with a D.
Infection.
Yeah, they're newly infected, or they're become newly infectious. We got to define. I'm going to be consistent. Up here it was infectious, so I think I'll say weekly infectious incident case count, just to be very clear about it. Infectious. So in other words, I'm counting the number that become infectious, not the number that just become infected. Okay, there we go. Ladies and gentlemen, there we go. Indeed. Okay. Okay. Oh, it's when someone's infected or become infectious. When do they become infectious in this model? Can anyone say? Under what condition do they become infectious? Where in the model do they become infectious?
When they're in the infectious state?
Yeah, when they come into this. So the entry action here, just like we turned a color equals red, we could increment those things. How would we increment these? How would we make these one bigger? First of all, where do they live? Where do these things live? They live where?
Main.
Maine. They live in Maine. Exactly. So we're going to say main dot. And we'll first do weekly infectious incident case count. Now, we could do this one of 3 ways. I'm gonna show you all 3. You can do this. This is a command. We're saying do this. Increment, add 1 to it. We're gonna set its current value. This is tallying it up. It's putting that stroke in to tally it up. Whatever it was before, make it 1 bigger. That becomes its new value. And that's okay. Another way that's kind of sweet is you can say plus equals 1, meaning it goes up by 1. This could be by 10, or it could be by 100 if you wanted it to be. But the point is that it's incremented by 1. You don't have to look. It's the same on the left and the right. Is it the same on the left and the right to figure it out what it's doing? Here, it just means add 1 to it. But there's an even briefer way we do it in Java and in C and C++ and it's ++. And you could pick your preferred way of doing it. If you want to do plus equals 1, that's fine. If you want to do this thing equals this thing plus 1, that's fine with me too. You can pick how you do it. I'm gonna, I think, click plus because it basically says increment it by 1. Boom. Short, simple, sweet. And I'll say main dot cumulative incident case count go up by 1. There we go. Okay. Great. Okay, that's great. In increments. Let's go run it and we'll see something. It won't be what we ultimately want, but it'll be something interesting. So let's go run it. I should have built. I'm sorry, I have sinned. I should have built it. Okay. By the way, we can see which person got infected. They're alone, and so the incident case count is 1 for the week, it says, and cumulative is 1, and now they've recovered, and nary will another infection happen. Here's another one, and this time it looks like I don't know where it's spreading. It just 1 as well. Okay, so it must have got infected like way the heck out there. Okay, now there's someone here who's getting infected and it's spreading. It says week. Okay, the cumulative 12, 13, 19, 80. 80 it got infected total. But you'll notice the weekly, it also says 80. Why is that? What are we not doing with the weekly?
Not resetting it at the.
Yeah, we're
beginning
not
of every
resetting
week?
at the end of the week. Yeah, we're just keeping on going up. And basically they're computing the same thing right now. So we got to reset it. We got to tally it at the end of the week. Okay, great. So where are we going to do that? Well, we'll set something that goes off periodically, like weekly. And this is a general pattern to report. We set something that goes off weekly. It's part of our observer processes. Fires off weekly. Do this, do this, do this, exactly week on week, like Old Faithful in Yellowstone. It goes off exactly on the week, and tally and you know, clears the slate, reports it, clears the slate, and we're done. How do we do that in any logic? What thing could we set up that might trigger periodically? We could do it from a state chart, but there's another mechanism we looked at, one that's in fact veritably staring us in the face, that can do something, I said, periodically.
An
Cyclic.
event?
An event, indeed, and it's an event. Here we go. It's an event. There it is. Event. Okay. And this event is going to, I'm going to say, weekly reporting event. It's going to go off. Is it going to go off once or cyclically? Anyone? Anyone? It's going to go off cyclically. And it will go off at timeout. Timeout means it's not based on some average rate. Sometimes it goes off faster. Sometimes, no, it's going off, you know, every week on the hour, so to speak, or every week at the exact beginning of the week. It's like a nightly census at midnight in a hospital or whatever. So the first occurrence time is 0 days, and the recurrence time is 1 what? 1. It's every what? Is it every day, or is it every? Begins with the W, ends with the K, and it's 2 E's in between. What is it? Week. Okay, it goes off every week. Okay, it goes off every week, ladies and gentlemen, because it's a weekly reporting event. It fires every week. And what happens at the week? It reports the number. It says, this is how many I've seen. We're going to get it to report it. I'm going to get rid of this cruft. I'm just going to get it to I'm going to say trace ln. weekly incidents for or incidents for week ending at time this was such and such. What is that such and such? Well, it's the value of this variable. Weekly infectious case count. Okay, now this is a mouthful, I know. And you haven't seen that before. So I'm gonna double click on this and zoom in and you could see it. Oh, not trace LM. Yeah. Okay. I'm gonna let you look at that for a moment. Okay. 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 So what this is doing is it's this point here is putting together these strings. So it's taking this string and it's sticking it together with the current time since model operation began. And it says after that was, so instance for week ending at time, whatever time it is, was such and such. Okay. Okay. Weekly incident case count. That's what it is. Okay. Great. Okay, so let's try that. And the only thing is we have a lot of cruft going on here. So I'm going to go back to person and I'm going to get rid of this. I'm going to comment this out. In any logic, you can comment things out with // and that's a Java comment. So you could say, don't bother with this. Okay, there we go. Okay. So make sure it builds, make sure it's happy. Okay, good. So what did we do? Well, in main, we set up a weekly reporting event going off cyclically on timeout every 1 week. And we said, hey, at that week, on the week, go and print out whatever this was. Now, there's still one critical thing we haven't done. And in fact, Amrita said it earlier, but we'll get to that. First, I just wanted to set up the mechanism to show it. Look at this. Instance for week ending at time 0 was 0. Ending at time 7 was 5. Okay. 14 was 43. That's an awfully big week. Okay. 21 is 80. It just seems to be going up. And that's not, in fact, you notice these are still the same. So Amrita, what still has to happen? What hasn't happened? You said it earlier, and
You haven't reset the count.
we have to reset it. So what do we reset it to? And at what point can we reset it?
At
That's
the
right.
end of the week, you reset it to 0.
At the end of the week. Do we do it before we report it or after?
After. Otherwise, it
After.
will report to 0.
Otherwise, it reports as 0, right? It's not really interesting. So we reset it. We set it to that. So every week we report it out, and then we set it to 0. So let's go see it. Let's go see this. Okay. Okay. And we see it reporting, and look, it's no longer going up. There we go. There we go. By the way, why are these going up by 7, 14, 21, 28? Why is that?
Because the unit of time for the model is days, so it's...
Yeah, and these are weeks. Yeah, exactly. If you look at the model as a whole, the unit is days. I clicked on the model as a whole and it's days. And so these are measured in days. I told you the model time unit sets what 1 means. So this means 7 means 7 days, 14 means 14 days, 21 means 21 days. Those are separated, those are different weeks, right? And it's reporting for each week. It's exactly right. Yeah. Okay. So that's nice, but it's reporting to let me show you a little bit. It's a slight tweak. I'm going to add something that's going to make this nicer. I mean, printing it out here is kind of okay, but let's get something that will regularize it. Go to analysis palette and add in a data set. Oh, I know your head is spinning. All these different things: state chart, an event thing, a variable, a parameter, a data set, an event, all these different mechanisms. And I sympathize. But data sets are really useful for exporting as well. So watch this. This will be called weekly incident case, weekly infectious incident case count data set. Okay. Doesn't leave much to the imagination, you got to admit. What it lacks in imagination, it makes up for in clarity. And I like to put these next to each other because they kind of sort of, pairs. They're like twins. Well, not twins, but they kind of go together. Okay, so this weekly reporting event is going to add to this guy. By the way, make this data set store more than 100. It's like this sclerotic sort of thing. It will start throwing them away after 100 unless you do this. Anyway, make this, instead of just printing it out, we will print it out, but we will also do weekly infectious count data set dot add, and we'll add it in. So you'll notice add allows you to add in just a single value, and that will pair it with the time. And so we'll add in this weekly infectious case count. So we're telling it, hey, add this value in. Okay. So it's a data set, and we add to it this latest weekly case count, and then we set the weekly case count to be 0. We reset it. There we go. Okay. So okay. So here we go. And it's reporting it nicely here. And now look, it also is in this data set. In the data set, ladies and gentlemen, the data set, we can export it easily. Click there, we go to this, and we paste it in, and we get our incident case count data set. Now, there's ways to export automatically to files. You'll find me covering online, and I could provide you code for that. And in fact, you'll find that in that lecture on observer processes. But basically, this is a nice way to sometimes export more informally. Okay, so now we see this, and we also have a cumulative case count. You'll notice that each of these is paired up with the time. So for the week ending at time 7, we had 4 cases. For the week ending at time 14, we had 39. For the week ending at time 21, we had 38. Week ending at time 28, we had 1 case. Okay. So that's sweet. Okay. Just 1 or 2 more things, and we'll be done with this. Okay. Okay, one thing we haven't done, I kind of feel obliged to do, is these should really be colored to indicate their kind of color that they have at runtime, so you can kind of know what color to expect from each. And gosh, there should be an orange. I think this is, no, it's gold. I don't know where orange is. Chosen colors, other colors. Oh my gosh. What is it? Is this guy orange? No, it's gold. I don't know what orange is. Is it this one? Navajo white. No, it's okay. I give up.
You can type in orange where it says chosen color.
Okay. Thanks, Wade. There it is. There it is. Okay. Okay. That's awesome. That's awesome, Wade. Thank you. Thank you. Okay. And so we want red here. Maybe this is crimson or something. Okay. And then we want gray with a A. No, silver. Okay, fine. So I'll say gray. Okay, copy. Okay. And then okay. There we go. Okay, that's beautiful. Okay. Everyone needs a Wade. That's great. Wade needs a Wade too. That's also important. Okay. Great. We've taken this model a certain distance, sort of upped its many strengths. There's a number of ways we could take this further. I could put in a mask use component of this, where people wear masks or not and interact with probabilities of transmitting and probabilities of being exposed based on, or sorry, infection given exposure based on the mask. That wouldn't be hard to do. I could, there was a desire for sensitivity analysis. Let's do that. Okay. So let's that was asked for before, and I feel